So this deals again with L'Hopital's rule. Which we know we have nothing to say about that. Indeterminate cases. As I mentioned a long time ago, there are seven indeterminate cases. And we looked at ratios, 0 over 0 and infinity over infinity. We looked at one difference, which is infinity minus infinity. So that's the second group. Third group, product, 0 times infinity. And we have powers, 1, 2, 3, 4. We have 3 powers. We have 0 raised to 0. We have 1 raised to infinity. And we have infinity raised to 0. So 0 raised to 0, 1 to infinity, and infinity raised to 0. So now I would like us to look and decide. We're going to have to stay on this for a while. So let's open on 4.4. I will too. And we'll practice limits. Needless to say, these are the most difficult. The powers are the most difficult. So what happens here is, L'Hopital's rule, as we remember, can be applied only in this situation. This is kind of rare to be able to change it into L'Hopital's rule, change this into these two. Very rare. I don't remember any case. So this particular one may not be transferable into L'Hopital's rule or transformed into a L'Hopital's rule, into these two, so I can apply L'Hopital's rule. But these have to be changed into this eventually to apply L'Hopital's rule. So that's what we're doing at this moment. Playing with these two again, and especially looking at the product to change it into this, and looking at powers to change it into these two so we can apply L'Hopital's rule. So that's our target for the next 20 minutes, half an hour, something like that. So I'm going to share my screen again. Oh, forgive me, I forgot to ask. Any questions on this, or is it clear? Any questions on this problem? Okay, well, you'll let me know. Okay, so back to okay, so it's a long list, as you see, from 8 to 70. All these deal with the 7 indeterminate cases, and some of them have L'Hopital's rule easily applicable, some of them not at all, and some of them more difficult to get to L'Hopital's rule, to make it, to change them into a L'Hopital's rule type of situation. So please choose whatever you want to start with, or I will choose, allow me to choose first, and then you will choose the next one. I would like to start with 22. And then you choose the next, please. There are many different situations here. Many. Okay, let me copy it and I'll stop sharing. X approaches infinity. Natural log the square root of x over x squared. Okay. So when we calculate a limit, what do we need to do first? Very good. Awesome. So obviously in this case, the numerator goes to
infinity.
Good. And the denominator to infinity. Yay! I don't have to do anything. I have to just simply apply L'Hopital's rule and I have to differentiate top and bottom. Anyone would give us the derivatives of the top and bottom? Anyone?
The top one is 1 over x.
Careful, you're right. It's 1 over the square root of x, but then times 1 over 2 the square root of x. So don't forget the 2. But you're correct, right? So the natural log prime is 1 over the square root of x, but times the inner function prime, which is 1 over 2 the square root of x, which eventually gets into 1 over 2x. I agree. But don't forget the 2. The denominator obviously is 2x. Okay, I continue. Limit as x approaches infinity. The top is 1 over 2x, and the denominator is 2x over 1. So this is limit as x approaches infinity. I flip the bottom fraction and I get 1 over 4x squared. And now the answer is
it approaches 0, right?
Very good. Y equals 0 because this is x approaches infinity and this is 0. Y equals 0 is a horizontal asymptote. Very good. Of course, at negative infinity does not exist. The function doesn't exist. I would say at infinity only. Always when I get something like this, when I determine x approaches infinity and I get a number, or negative infinity and I get a number, I have to state this. Good. Back to sharing. Have you chosen the next problem?
Or how about 26? Yeah.
26. I knew Mark would say that. No, I didn't. I did not at all. I'm not really good at guessing. So limit u approaches infinity, e to u over 10 over u to the third. Okay. Very good. How do we start?
We plug in.
Yep. So then the top goes to
Top goes to infinity.
good. And at the bottom, so yay, not a big deal. The denominator is 3u squared, and the numerator is e to u over 10 times
U over 10.
1 over 10, right?
1 over 10.
Good. So now let's take a look what happens here. So this is basically 1 over 10 over 3, so that would be 1 over 30. You can go outside and wait patiently because it's a factor. E to u over 10 divided by u squared. And now, anyone else will tell us what to do next? Anyone I haven't heard yet? Kush, do you want to continue here? What do we do next? Okay, anyone else?
You said it equal to 0?
I can't. I'm determining the limit of a function when u approaches infinity. I cannot set anything equal to 0.
Can we keep solving?
Exactly. So this, yes, because it's infinity over infinity. That's why. Otherwise, I can't apply L'Hopital's rule. So it's 1 over 30, and limit u approaches infinity. I differentiate that again, which is e to u over 10 again times 1 over 10 over 2u. I have now a 1 over 20 multiplied by 1 over 30, which is 1 over 600. Limit u approaches infinity from e to u over 10 over u. And what next? Yes, still infinity over infinity. So this is 1 over 600, limit u approaches infinity. So this is u over 10 times 1 over e raised to u over 10 times the inner function prime divided by 1. So 110 goes in front if you want, it's 1 over 6,000. But then I have to determine the limit as u approaches infinity from e to u over 10. So what is this equal to? Anyone?
Is it infinity?
That's it. That's it. That's it. As u approaches infinity, e to infinity is infinity. The number in front is too small to make any difference. Very good. Awesome. Thank you. Any questions on this? Okay, so far we experienced the infinity over infinity. I would like to allow me to choose the next one, because I think we got the idea about infinity over infinity and 0 over 0 will be treated in the same way. Okay, I would like to continue with 44. I'll copy it, so limit as x approaches infinity from the square root of x e to negative x over 2. Okay, I'll stop sharing now. Okay, so let's see what happens here. As we need to look at all different types, all 7. So I consider this the same with 0 over 0, so we know already 2. Okay, so how do I proceed here?
This is the product rule.
Exactly. So this one will approach what when x approaches infinity?
Infinity.
Very good. Where does this go? Well, let's take this piece first. Where does this piece go when x approaches infinity?
Negative infinity.
Yes. So this approaches negative infinity. Where does e to negative infinity go? It's the same with 1 over e to infinity.
0.
That's it. So that's the problem. So this is the product. Where is it? Right here. 0 times infinity or infinity times 0 is the same thing. Doesn't matter. Good. So then this is the product of 0 times infinity. Now, in this situation of the product, what we try to do is an algebraic manipulation. This is what we're trying to do. To manipulate this function algebraically to change it into 0 over 0 or infinity over infinity. To change it into, infinity over infinity or 0 over 0. Because that's what I need in order to be able to use L'Hopital's rule. So, this is very clear, it's the square root of x. I'm not going to do anything to it. But this one has a negative power. So anything that with a negative power can be rewritten. How? So I'm going to continue here. So I have the limit as x approaches infinity, and I have the square root of x, and what can I do with e to negative x over 2?
You can put in the denominator.
Excellent. Thank you. I know it's Jordan. Okay, so now it's fine, right? Infinity over infinity, all clear, I'm done. I use L'Hopital's rule. The numerator goes to infinity, the denominator goes to infinity, so then limit as x approaches infinity. I differentiate the top, who will tell us the derivative of the top and the derivative of the denominator.
The the top is going to be 1 over negative 2x.
Careful.
Negative
1 over
negative
2.
2 square root of x.
Yeah, just it's positive. And the denominator is e to x over 2 times the inner function prime, which is 1 over 2. 1 over 2 from the top with 1 over 2 from the denominator, they are factors. I can simplify them. So I have limit as x approaches infinity. The top is 1 over the square root of x, and the denominator is this over 1. When I flip, I get both in the denominator as the square root of x times e to x over 2. This approaches infinity, this approaches infinity, the whole thing approaches or equals in this case with a limit operator in front. That will be anyone, Javon, Carson, Tan, Josh, anyone? So if I have $1 and I want to divide it by 1 million people.
Zero.
Okay. I want to count my zeros here. Yes, it is 0. So y equals 0. When I have x approaches infinity and I get any number here, I have to write y equals 0. Horizontal asymptote at least at infinity. Good. So we encountered the product. So we have 3 now. So the difference is normally either rationalized or anything else. It's not really the L'Hopital's rule. So now we have to focus on the powers, but I will also try to find an infinity minus infinity. So products, remember, algebraic manipulation, and